Hello and thanks for tuning in. This screencast covers the concept of percent yield. To understand this, you need to know a little bit of terminology. The first term is the theoretical yield. This represents the maximum amount of product that could theoretically be produced. This number is calculated using the balanced equation. This is your ideal pie in the sky number that if everything happens perfectly in the lab, every atom goes exactly where it's supposed to go, nothing is lost by error or to the environment, this is the amount of product that you would get. This number is calculated using the balanced equation, so you'd pretty much do a roadmap problem. You start with 10 grams of reactant, do a roadmap problem, including the mole ratio step, and you get 15 grams of product. That 15 grams of product would be your theoretical yield. That would be the amount that you would expect to get after you do a roadmap calculation and assume that nothing is lost in any way, shape, or form. But that's not the case, and this is where the actual yield comes into play. This is the actual amount of product obtained when the reaction takes place. This is determined experimentally. And in a problem, and you'll see this in a few minutes, this is the number that will usually be presented to you as you did the experiment, and this is the number that you got. Actual yield is typically going to be less than the theoretical yield. It's much easier to lose material in a lab than it is to suddenly gain material. For example, if you expect to make 10 grams and you only end up making 8, the 2 grams that were lost could have been lost a number of ways. They could have been lost by spilling some contents onto the lab table. It could have been lost by an error at the balance where you didn't scoop out everything that you were supposed to scoop out, or quite frankly, it was probably due to that lab partner that you were assigned randomly. Let's be honest. The percent yield, though, is a ratio then of the actual to theoretical, and it's just that actual divided by theoretical multiplied by 100. Of course, it's a percent, so it'll have a percentage at the very end of it. Here's an everyday kind of easy to understand problem. To calculate the percent yield, you need obviously both the actual and the theoretical yields. Let's say that you prepared cookie dough to make 5 dozen cookies. The phone rings, you answer while talking. A sheet of 12 cookies burned, and you have to throw them out, and you can't bring them to chem class. The rest of the cookies are okay to bring. What is the percent yield of edible cookies? Well, you expected to make 60. You had materials to make 60, but you actually only made 48 cookies that were edible. So the percent yield, 48 divided by 60, of course, multiplied by 100 will then give you 80% yield. Now in chemistry, a problem might look like this. Without proper ventilation and limited oxygen, the reaction of carbon and oxygen produce carbon monoxide. The reaction is listed here, 2C plus O2 makes 2CO. What is the percent yield if 40 grams of carbon monoxide are produced when 30 grams of oxygen are used? Since we're solving for percent yield, again, we need to, in this case, know what the actual amount is and what the theoretical amount is. And we can then divide those two numbers, multiply by 100, and then get our answer. Um, in this case, we have the mass of one reactant, which is the 30 grams of oxygen, and the mass of a product that you end up making, 40 grams of carbon monoxide. So if you used 30 grams and you made 40 grams, because it says 40 grams are produced, this number right here, I would identify this number as your actual amount. This is the amount that you actually made in this experiment when you ran it. But that's not the theoretical amount. In theory, if you start with 30 grams of oxygen, you'll end up making, potentially making at least, a different amount of carbon monoxide, which would then yield a different percentage. And to figure that out, simply all you need to do is just do a roadmap problem. If you have 30 grams of oxygen, which is right here, I would divide it by its molar mass of 32, do a mole ratio, 1 mole of O2 to 2 moles of CO, and then in this case multiply by the molar mass of carbon monoxide. 16 plus 12 is going to be 28 grams. And to show this, including the answer, here we go. You will indeed have a 76.2% yield, and here are the steps that I outlined a second ago. Dividing by the molar mass of oxygen, there's your mole ratio 2 to 1. There's your very precise molar mass 28.01. That gives you the theoretical amount. This is the amount that you would expect to have if nothing was lost to chance, the environment, etc. 52.5 grams. Now to percent yield, 40 grams, that was the number that was provided. 52.5 grams is the amount that you obtained stoichiometrically, in other words, using a roadmap problem. Multiply by 100 will give you 76.2%. In the past, I found that students have had trouble with these types of problems because they usually misidentify the actual amount or the theoretical amount. So you have to really take care when reading a problem like this to realize what this number here represents. If 40 grams are produced, this is that mass is the mass that is produced. That's the actual amount that you make. So that would be, of course, your actual yield, not your theoretical yield. So be careful when you read these. Sometimes it can be a bit tricky. And what I would urge you to do is to always write out the equation involving whatever it is with percent yield that you're trying to do. So I always write actual divided by theoretical times 100 equals percent yield. Since I'm solving for percent yield in this problem, I know that then I must have the actual and the theoretical numbers to determine that percent yield. Here are a couple of steps to follow. It's a nice colorful little flowchart in terms of what to do these types of problems. Step 1, write the given and needed quantities. In other words, write out what you know, write out what you're looking for. Step 2, write a plan to calculate the theoretical yield and the percent yield. 3, write the molar mass of the reactant and the mole-mole factor, in other words, the mole ratio from the balanced equation. And finally, solve for the percent yield ratio by dividing the actual by the theoretical and then multiplying by 100%. Here's another problem. When nitrogen and 5 grams of hydrogen are mixed, the reaction produces 16.0 grams of ammonia. What is the percent yield for this reaction? There's 3 possible answers here. One of them is correct and the other 2 are not. Take a moment, pause this, use the previous example as kind of a template, and solve for this. Solve for the percent yield for this problem, and then I'll come back in just a moment after you unpause and walk you through this. The actual answer will be 56.7%. Based on the balanced equation right there and the mass provided, the 5 grams of hydrogen, you divide by its very precise molar mass of 2.016, molar ratio is 2 to 3, and then multiply by another very precise molar mass of 17.03 grams of ammonia, which will then yield 28.2 grams. This is your theoretical amount. This assumes that all 5 grams go through the entire reaction perfectly, nothing is lost to chance, the environment, etc., and the amount that you would expect to get would be 28.2. According to the problem, that's not what you got though. You only got 16 grams, so that must be your actual amount. 16 divided by 28.2 multiplied by 100 then will give you 56.7%, and that is your percent yield.